All right, this is lab or project 4 for CCS 447, final project of the year. So we're taking a smartphone, we're connecting it with a 2.4 gigahertz wireless device through the serial Bluetooth module. Then we're going to connect it to a microcontroller, then send messages through the IR receiver module, which through no small amount of effort, I could not get functioning, which is unfortunate. But the professor did say that he would show how the IR system works. I did ask several classmates and different people in my class, as well as search through online, and found no solution using the TM4C. I did, however, find solutions using Arduinos, which doesn't translate exactly, and due to the limitations of the datasheet, made it kind of difficult to actually solve. So in lieu of solving that, just to get the system working and demonstrate that the functionality can be done, I just used a simple UART connection as a substitute. And then due to the fact that I'm using one board as opposed to two boards, as you can see, my configuration down here is a little messy due to all the wirings. The microcontroller just connects back to itself through a separate UART port, as done in previous labs. The 8-bit DAC output going out to my speaker here. The ST7735 color LCD display here connected to the system through the microcontroller. Let's see. All right, so there are 7 commands that are going to be sent through the UART system. A 0 does command 0, and all the way up to 7, respectively, command 7. The LED functionality displaying the bits was omitted by the professor, so that was in fact omitted from my lab. However, if included, one could assume that when you send a data stream that is longer than just a single bit, as done in my lab, you could send both this command here, 0B10, which I assume would mean the binary equivalent of the address, which would then translate to the device number and display the proper according LED. However, there's no functionality for the LEDs, to my understanding. Like, there's no correlation between the device number and what is being displayed. So it makes sense to omit that from the lab. And then the command here itself is just the 0 through 7 that's being sent through the UART, through the Bluetooth, to the second microcontroller, or the simulated second microcontroller. And that's about it. And then you just send those commands, and then it does on 0 through 3. It'll do different animations, or in my case, pictures, just changing the color just to determine that the animation does work, that the code does work. However, I didn't want to waste a bunch of time creating animations, as that does not actually change the functionality of the hardware. It just, sort of brownie points on my artistic skills. So that was omitted for time, to give more time to work on the IR. And then the output here of a 2.6 or 262 hertz wave, sine, square, and triangle, and sawtooth. And then here's the video we're going to demonstrate. So here in the code, we can see my main function. So enabling different prototypes. Main function here, disables interrupts, enables all the UARTs, the DAC, the PLL. Doesn't really need the port F, that's just left over. A little bit of a test code here to determine and validate that my functions are working properly. And then when you go into the main while loop here, you have the input through the UART2 inchar. Then it determines the Bluetooth readout. So when you send the single char through the Bluetooth, it receives, or from your smartphone to the Bluetooth, it receives it and stores it in this location. And then this here is the substitute for the IR, where we're passing from one UART port to the next, simulating 2 boards that could either be connected physically by wires, or could be connected through separate Bluetooth modules, which would make for some really interesting wireless connectivity. The UART outchar here just was a test to show that as I'm doing my testing and proving that we're displaying the sine waves and we're displaying the things that we're displaying, we can actually see those images over here. And since I'm going to be recording this on my phone, there will be no way to really show what is actually going on my phone other than explaining what I'm doing with the phone as I'm doing it, and then subsequent screenshots of the screen showing that the functions were indeed typed at that timetable. All right, and then here's the main switch case. This is what I use for cases 0 through 7. So on 0, we're going to create a circle that's colored yellow. On 1, we're going to create a red circle, and then 2 is a blue circle, and 3 is a cyan colored circle. Case 4 here is, oh, you know what? Let's go ahead and just demo these here, and we'll give you an idea. Well, no, let's just continue to go through the code, and then we'll just show you them all. So case 4 here is the sine wave output. Case 5 here is the square wave, triangle wave, and sawtooth wave, all at the 262 hertz triangle wave. And that's about it. And if you don't do what you're supposed to do, you input anything else, it just turns the sound off. And that's the code. DAC here is fairly similar from the last lab. You just do a sound init. There's a new flag in here with a sound off function that turns off the sound. DAC out, doing the different waves. If sound's on, you output the things. Otherwise, your stuff gets nothing. So that's new functionality. Hopefully it works out. It's been finicky, but I think that's due to the noise and the way that I set up my capacitors. I think there's just a lot of leftover residual voltage flowing through the circuit that's causing, plus it's all connected to the same ground, so it's not the most efficient management due to having only one board for all these devices, and ground's all going to the same. What else here? So UART's pretty standard here. UART 3, 4, just connecting from board to board. UART 2 here is connected to the Bluetooth at the 57600 baud rate, 8-bit word length. UART 1's not being used. UART 0 here we have for the serial terminal at the 115200 rate, which we're display on the serial terminal here. And that's all the code. So let's go ahead and start issuing some commands here, and we'll do that in part 2.